So continuing on within subject designs, and again, a within subject design means the same participants are being exposed to all levels of your IV or IVs. One of the big problems we have to worry about beyond some of the other things we've talked about is basically the order effects. And we kind of talked about multiple ways order can affect the outcome of your study. And a lot of these can be sometimes fixed with timing changes. So can counted practice and fatigue, we can counter fatigue and practice effects by adding a time period between the exposure to levels of the IV. So that's one of our first tools. And so, for example, if I'm bringing people into a study and I'm having them do 3 conditions all in the same day right in a row, that's probably where we're going to find the biggest practice effects. That's probably where we're going to find the biggest fatigue effects. That's where we're going to find a lot of these problems. One of the things we might do is simply add a bit of a time period between exposure levels. Now, what is a good time period? Generally, we want a long enough time for people to forget the previous condition they were in, at least within details, and their exposure to that DV, without adding so much time that we start to open ourselves up to the potential that the participants are changing during that time. A lot of times this might be 1 or 2 weeks between each participant exposing the condition. So we have a bunch of participants. Let's say we have a sample of 30. We bring them in and expose them to the first level of our DV on week 1. They experience the study. They experience our IV, at least 1 level. They then fill out the DV and they're done with the study. We then bring them back a week later and have them do the second version of our IV, in other words, the second level. And then again, once again, a week later, we have them come in for the third. Now, this is not a perfect fix, but one of the problems that can occur with this one is you may actually experience people that drop out of your study. In other words, they participate for the first time and never come back, or the first or second time and don't come back for the third. That's lost data at that point. So if you're going to use time because you're worried about fatigue or practice effects, you probably want a slightly larger sample size to account for the fact that you might have some drop-off in participation. And again, the longer we wait, the more likely that events may actually occur that become noise themselves. So I used an example in class the last lecture of a study that was looking at basically anxiety about world events that was occurring in New York at the time that 9/11 happened. So they were doing a within participant design where they were slowly working with a group of students, children mainly, and also looking at the effects of various treatments on basically alleviating anxiety on world events. Unfortunately, due to something completely out of their control, a huge event happened that disrupted their study, and everything that occurred after it, the levels of anxiety within that population were much higher than they'd been prior, having nothing to do with the study itself. So just recognize that though this can affect things, it does open yourself up to potential other problems. Now, sometimes we can just fix this with randomization. In other words, we randomize small number of levels of an IV. Each participant will encounter the levels in a random order. In other words, we are no longer using time. We're basically bringing people in. Yes, they're going to be exposed to all 3 levels at one time, but to try to get rid of practice, fatigue, or even contrast effects, people's exposure to those conditions is randomized. So again, if I have control, moderate treatment, extreme treatment, some participants randomly will get control, moderate, extreme. Some will get moderate, control, extreme. Some will get moderate, extreme, control. And then finally, those final combinations of extreme, moderate control and extreme control, moderate. You basically want to make sure when that you do this is that you have a randomization across all possible orders of encountering your IVs, so that you can make the argument, if there was fatigue effects, the noise is still there, but I'm making sure it's no longer a confound. I'm spreading it equally. If people were fatiguing out by the third condition, well, a third of them got condition 1 as the third condition, a third of them got condition 2 as the third condition, and a third of them got condition 3 as that third condition. So this is often referred to as counterbalancing or complete counterbalancing. All possible combinations of the IV conditions condition orders are presented across the study. The advantage of complete counterbalancing is that you can capture all possible orders, but this can sometimes be very difficult with multiple conditions. So for example, with 3 conditions, as the example I mentioned on the last slide, there's 6 orders of conditions. 123, 231, 132, 312, 213, 321. So even with just 3 conditions, we're basically looking at 6 potential orders that we have to randomize people into. And that means that every time we run this study, there is 6 possible ways we'd run the study. If we had just one more condition, 4, it becomes 24 orders of conditions. So sometimes we may not use complete counterbalancing on larger, more complex studies, but we still might try to make sure that there's an equal number of times that someone is in condition 4 last, second to last, second to first, and first. So there's 2 things we can think about when we're counterbalancing. Are we simply counterbalancing, or are we complete counterbalancing? If you're doing 2 or 3 conditions, you should probably do complete counterbalancing. Beyond that, you may just try to counterbalance to ensure that the order effects are somewhat there. Now, what you're losing if you don't do complete counterbalancing is the contrast effects may be a problem still. The only way to completely remove contrast effects from being a potential confound is with complete counterbalancing. In other words, every possible combination of orders is equally presented. Now, also think if you've got 24 orders of conditions and you only have 30 participants, are you actually going to randomly get enough people in each one of those conditions to really make that argument? And that's the other problem that you have with complete counterbalancing. Complete counterbalancing also means you often need a larger sample size. So with more cases, you can use partial counterbalancing. Present just some amount, but not all of the possible combinations of the IVs, conditions, orders. And the idea there is to try to basically come up with at least an order where everyone's exposed to each IV in each position approximately an equal amount of time. We'll often do this if there's just not a large enough sample to use complete counterbalancing. And often what we'll do is use what's called a Latin square. So a Latin square is the most common use type or model, if you will, for partial counterbalancing. Every condition occurs exactly once in each row and column in different orders, randomly assigned to those orders. So let's take a look at an example of a Latin square. So this would be an example of an IV with 4 levels. So if we were doing complete counterbalancing, we would have 24 orders. Now this would get rid of potentially any argument of fatigue or practice and any argument of contrast effects. But we need a pretty large sample and we would need 24 different ways of running the study. Instead, we might do a partial counterbalancing using a Latin square. Each condition appears once in each possible order of conditions. So again, we have 4 conditions. And the first one, you get it 1, 2, 3, 4. The second one, you get 4, 1, 2, 3, then 3, 4, 1, 2, then 2, 3, 4, 1. Notice if you follow the diagonals are the same number. So diagonal is the condition 1 appears in the first position, then the second position, then the third position, then the fourth position. This means that everyone that goes to this study has an equal number of times they experience 1 as the first, second, third, or fourth condition. Now, this does not get rid of the potential of contrast effects because there are some contrast effects here. For example, 2 almost always follows 1 except for in one condition. 4 is almost always actually preceding most conditions. So 4 is almost always in front of 1. So there is some potential contrast here that is not being completely gotten rid of, but you're still at least addressing some of these order issues within participant design. And I want to stress that again, that these techniques are not for between subjects. If you've got different people in each condition, you're not having to worry about order effects, contrast effects. Probably worrying less about fatigue, and if there is fatigue, it's equal across all your conditions. This is when we're actually using within participants, and we're recognizing that there may be an issue with how they're experiencing the levels of our IVs, because they are experiencing all levels of our IV. So when we're thinking about whether or not we want to do a between or within participant design, we want to consider order effects. Even when you're not too concerned about order effects using within subjects, you do need to control for them and at least consider them. And if they're a big issue, that may be a reason to not do a within subject design, do a between subject design. Of course, we have to ask how many participants can we readily get. And generally speaking, it is usually statistically easier to do a between subject design if you have a large access to a large sample pool. In other words, if you can get a lot of participants, between subject designs, though a little less powerful, have a lot less concerns with generalization and internal validity. Within subject designs are usually going to be used when we have a serious issue with just the number of participants we're going to have access to. If you are concerned with changes in your participants within the time period of your study, again, we're probably going to go, if we can, with a between subject design. If our IV causes changes in stress, mood, substances, then we probably can't use it within subject design unless we again put large periods of time, usually at least a week, between each condition. So for instance, if I have a condition where I'm trying to reduce stress or increase stress, the order you get those in, if they're in the same day within participant design, is going to cause major contrast and carryover effects. I would probably want to split that up by a full week at least. So again, when you're deciding between and within subject designs, there's numerous factors. You want to think about what are you worried about, what are you trying to do, and how big of a sample do you have access to. Both of them have strengths and weaknesses. Both of them have advantages and disadvantages. Between subject designs tend to be simpler to address their disadvantages. Within subject designs are definitely addressable, but often involve a little bit more thought and a little bit more care with how we're doing it if we're worried about these potential problems. So again, just a quick idea between and within participant designs. This is also just to kind of help you visualize it and also to make an argument as far as which one is more powerful. So in a between subject design, if we have system A versus system B, two interventions, we're going to have 8 participants in the first group, 8 participants in the second group, but they're different people. We're going to be able to look at their mean differences, and different people are in each condition, and we get those mean differences. When we look at a within subject design, it's the exact same people in both conditions. And this often means that the differences found can be actually smaller, and we can still find statistical significance. Like I said, within subject designs are more powerful.